With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello friends, welcome to Doubtnut. Our question is the set of point of the differentiable of the function f of x is equal to under the root x plus 1 minus 1 upon under the root x if x does not equal to 0. If x is equal to 0, our function is 0. Our option A is all real number, option B is 0 to infinity, option C is minus infinity to 0, option D is all real number except 0. Note that in our question we ask about the differentiability of function. Okay, we ask about the differentiability of function. As we can see, our function having a term under the root x plus 1 and under the root x. Note that if any number lie inside the square root is negative, then function become a imaginary. Okay, but which is not valid because our function is a real function. Hence the domain of our function is always x is greater than 0, because if x is greater than 0, this is square root and this square root become a positive number, positive real number. Okay, in this way domain of our function is always greater than 0. Okay, now we have given also at x is equal to 0, our function is 0, so 0 is also included. Now as we can see, our function f of x is equal to square root of x plus 1 minus 1 upon square root of x. If x does not equal to 0, it becomes 0 if x is equal to 0. Now for differentiability, first differentiate this function. So if I differentiate this, differentiate with respect to x. Okay, now if I differentiate, then we apply the chain rule of quotient rule of differentiation. What is quotient rule? D by dx of rational function is equal to leave the denominator as it is and differentiate the numerator, minus leave the numerator as it is and differentiate the denominator, and the whole term is divided by square of denominator. Okay, now in our case f dash x is equal to, if I differentiate this, then what we can do, our denominator is root x, then differentiate the numerator which is equal to under the root x plus 1 minus 1, minus leave numerator as it is x plus 1 minus 1 and differentiate the denominator. This whole term is divided by square of denominator if x does not equal to 0. Okay, and if x is equal to 0, our function is 0. Okay, now what we get? We get f dash x is equal to, as we can see, the differentiation of this whole term is what? 1 upon 2 square root of x plus 1. Okay, so it become under the root x upon 2 time of under the root x plus 1, minus this whole term remains same, under the root x plus 1 minus 1, and differentiation of root x is 1 upon 2 root x if x does not equal to 0. Okay, if x is equal to 0, okay, and the whole term is divided by square of square root. Okay, that means x, and this function is become 0 if x is equal to 0. Okay, now what we get? We get our f dash x function is become, if I take LCM, so what is the LCM? LCM is 2 root x plus 1 into root x. Okay, so what we do? We multiply only root x to this term, so we get root x into root x is x, minus root x plus 1 time root x plus 1 minus 1 if x does not equal to 0, and if x is equal to 0, our function is 0. Okay, so what we get? We get our f dash x is, our function f dash x is what? F dash x is x minus x plus 1 minus under the root x plus 1 is whole divided by 2 time of under the root x plus 1 under the root x into x also if x does not equal to 0, and if x is equal to 0, it becomes 0. Okay, so as we can see, x and minus x both are cancelled. So remaining term is minus minus plus 1, remaining term is under the root x plus 1 minus 1 whole divided by 2 time of x under the root x plus 1 if x does not equal to 0, and if x is equal to 0 this becomes 0. Note that this is our f dash x. As we can see, our f dash x is defined everywhere if x is greater than 0. Okay, because if x is greater than 0, then our whole denominator term is a finite and non-zero value. Okay, finite, real and non-zero term, and this numerator is also finite and real. Okay, so this whole term is defined and continuous everywhere if x is greater than 0. Hence our f dash x is exist. So our f dash x is exist if x belongs to 0 to infinity. Okay, that means our function is differentiable for all x belongs to 0 to infinity. And if x is less than 0, then this whole term become a imaginary. Okay, which is not valid. So our true option is option number B. Okay, option B is true. Hope that you clear this question. Thank you for signing Doubtnut.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.